Hey guys, welcome back. We'll continue our series on automating the boring stuff with Python. In this chapter we are covering functions. You can find the book for free on automatetheboringstuff.com, and if you prefer a physical copy, there's a link to the book in the description down below. Also feel free to subscribe to the channel to stay up to date whenever a new video is released. So we already saw some examples of functions before, for example the print function, the input function, or the length functions. And now we are going to understand a little bit better what functions are actually used for and how they work. So let's first of all have a look at an example. We can open our code editor mu and then create a new Python file. We can call it hellofunc.py. And here we are going to write our first own function. And this is what we're going to write. We are going to use the def keyword. That's always required to define a new function. Then we write the function name, in this case hello. We have parentheses behind that, a colon, and then we indent the next lines of code. Everything that should be part of that function is included here. So in our case we have three separate print statements. And once we defined our function like that, we can call our function by just typing out hello with the parentheses, and we call our function 3 times. So let's run our program. And we can see that we actually have quite a bit of output here. So we can see whenever we call hello, we're printing howdy with 3 exclamation marks, and then hello there. So we print that out a total of 3 times. And here we can already see a benefit of using functions. Rather than having to type out all of these 9 lines that are being printed out, we can just define our function and call our function a couple of times. And this is going to make our code a lot more reusable and also more compact. Rather than using a function with empty parentheses, we can also enter an argument. So here we have another function called, again, hello, but here we pass a name to it. And that's the parameter that we define. So here we say we take a name and then we print hello name. And when we call this function, we pass an argument to it. So here we say Alice or Bob. And let's run that program to have a look at that, and we can see it prints out hello Alice, hello Bob. So this is how we can customize our functions a bit more. And just a note on that. So when we pass an argument to a function, actually when we define a function, it's called a parameter that we provide, or multiple parameters. So we, for example, could add a second parameter here, separated by a comma. And then when we call the function, that means when we actually trigger our function, then we pass an argument to it. So when we pass a value to it, when calling the function, it's called an argument. When we define it, it's called a parameter. Now our functions cannot only print out something, but they can also return a value. And for that, let's have a quick look at our REPL environment. So here, for example, when we take our length functions from before, just as a reminder, that returns that shows us how long, for example, a string is. So if I call len on hello, for example, we get back 5. That is the return value here. And the return value can be a number, for example, it could be a string, or it could also be none, which is basically showing that nothing is returned from a function. Let's actually have a look at working with return values. And for that, we are heading over to another Python program, magic8ball.py. You can find the entire code, of course, in the book. So here we are first importing the random module as we did in the last video, and then we are defining our function called getAnswer that takes an answer number, and then we check using an if and a couple of different elif statements what kind of message will be returned when a certain number is displayed. And here at the bottom we are using the randint function from the random module, and we get a random number between 1 and 9. And then we pass that random number to our getAnswer function up here, and depending on which number we pass to it, an answer number, we are going to get back, or we are going to return a certain string. And that string is assigned to fortune, and we are printing it out here at the end. So let's run our program, and we can see in this case we get back it is certain, which is corresponding to answer number being equal to 1. If we run that again, we get back my reply is no, which is equal to the number 7. So to return a value, all we need to do is to type in the return keyword as we see here, and then after that we write the value that should be returned from our function. And then after that, we write the value that should be returned from our function. And as briefly mentioned before, it's also possible that a function does not return any value. So as an example, let's say we have a variable called spam, and here we assign to it the return value of calling the print function, which of course prints out hello. So first of all, when we do that, the print hello will be executed, so hello is printed out. And now we can actually compare the value none. Again, it's important to capitalize the n at the beginning, just as we did with true and false before, the Boolean values. If we check none and we compare it to the value of spam, we get back true. So that shows us that spam indeed is equal to the value none. So that means that print returns none. So behind the scenes, Python actually adds the return none to the end of any function definition with no return statement. So that's similar to how a while or for loop implicitly ends with a continue statement. And also if we use the return statement without providing any value, so for example if we do this, then we are also going to return none. So we could either write return none or we could just write return. In both cases it will return the value none. Now when we work with functions, most arguments are identified by their position in the function call. So for example, if we take a look at such a function here, so we are importing the random module and we're calling the randint function out of the random module, and we pass two arguments to it, 1 and 10. If we run it like that, we get a random number between 1 and 10. But if we were to change out the order of those arguments and write 10 and 1, that's actually invalid. So in this case, we are going to get an error. So it's really important in which order we actually pass the arguments to our function. However, there's an alternative approach that we can take. Rather than passing the arguments by their position, we can pass keyword arguments. So basically, we pass in the keyword and then the value for an argument. Let's have a quick look at an example. And let's say we just have two print statements. One prints out hello and the other one prints out world. When we run that, we can see that both of those lines are printed just below each other. The reason for that is that the default behavior for the print statement is actually to add a new line at the end of the print statement. And therefore we have those two print statements in separate lines. But we can use a keyword argument to actually change that. So after hello, we can add a second argument, and we're going to use a keyword argument. So we're passing end to it, and that's an optional keyword argument that we're adding. So we can see we type in the keyword for that argument, then an equal sign, and then we pass a value to it. In this case, we just want to use an empty string. So now if we run our program again, we can see that rather than having a new line added in here, hello world is actually printed out in a single line, and that's because we changed the end character here of the first print statement. Let's have a look at a different example. We are printing out three different words here, cats, dogs, and mice, and we can see by default they are separated by a space character. Again, that's the default behavior for the print statement, but we can change that. Again, we can use an optional keyword argument to change the separator, and let's say we are going to change it to a comma. And if we run that again, we can see that it's now separated by a comma. And of course we can pass any value as a separator in here, and that's going to be used in the statement. We can also add keyword arguments to the functions that we are writing ourselves, but in order to do that we need to learn a little bit more. We're gonna get back to that topic in about 2 videos. Importantly, when we work with functions, they are often nested inside of each other. And there's something called the call stack that basically determines in which order different functions are executed. So let's have a quick look at an example that is unrelated to code for now. So let's say we tell somebody a story and we talk about a number of different people. Let's say, for example, in the beginning we tell a story about Alice, then we interrupt the story to talk about Bob, then we talk about Carol, then we finish the story about Carol, we get back to Bob, and then we get back to the original story. In this case, we are basically talking about different kinds of people without finishing one story after another. And this leads to this kind of stack-like structure where we basically talk about an additional person and our stack gets larger, and when we finish the story about a person, then basically we remove the stack and we talk about the next person after that. So let's have a look at an example of using a call stack in Python. Here we have 4 different functions that are being defined, A, B, C, and D. And those functions in turn call other functions. So for example, here in our A function, let's printing out A starts, and then at the end A returns. But in between we call other functions. So in this case we are calling B, and then here we are printing out B starts and B returns, but in between we are calling C. And then here C just prints out that C starts and C returns. And then we basically continue with the next step. So if we run that, we can actually see that when we call our function A, which is called here at the very bottom, then we are printing out A starts, and then at the very end we are printing out A returns. So everything in between happens basically in other functions. So here we're calling B. Now we basically add to our call stack and switch over to the second function. Here we're printing B starts, which we see here, and then we go even one level deeper, if you will. So we add to our call stack and we call function C, and that prints C starts and C returns. Now when the execution returns from C here, we continue with B returns. So here we're basically ending the execution of B. So we get back to our A function, we call D, and D just prints D starts, D returns, this here, and then it returns back to our A function, and here we're printing A returns. So we just follow the execution of A pretty much, but this function in turn calls other functions, which in turn call other functions. So we can go pretty deep using this approach. And whenever we call another function, Python creates a frame object on the top of the call stack. So to display that visually, this is basically what's happening. We start by calling our function A, then A calls B, which adds a frame object here and adds to our stack. B calls C function, and then C stops execution, and we continue basically. B stops executing, we go to A, then A finally calls D, and finally A, and then our stack is basically empty. So we don't really need to know too much about this call stack in practice, but it's kind of good to understand what's happening behind the scenes so we can better follow the flow of our programs. So parameters and variables that are assigned in a called function exist in the function's local scope. And basically anything outside of that local scope cannot access that variable. And therefore variables inside of that local scope are called local variables, and variables that exist outside of a function are called a global variable in the global scope. So we can think about scope as the container of a variable. It's either in the global scope and can be accessed from anywhere inside of our program, or it has local scope and is therefore only accessible within the scope. So for example, within the function. In scope, it's quite important because the code in the global scope outside of all the functions cannot use any local variable, but code in a local scope can actually access the global variable. And we can even use the same names for global variables and local variables. That's called shadowing. And in general, in small programs it's fine, but in general we should avoid using global variables because they're kind of bad practice, and they can actually have some consequences that are unintended. So in general we should always work with local scope. So let's have a look at an example to make that a little bit more practical. Here we have a function called spam, and inside of spam, inside of the scope of the spam function, we assign a local variable called x and set it to this value. Then after that we call spam and we try to print out x. And the call to spam and printing out x, that happens in the global scope outside of our local scope. And as we just learned, we don't have access to the local scope of variables in the global scope. So if we try to run this program, we see we get a name error because the name x is not defined. And that's indeed true. X is not defined inside of the global scope, only in the local scope, but we can't access it. So we can't look inside of that function and get this value here outside of that function. If we were to do the following, if we define x outside of the variable, and let's just set it to something else so we can compare it, then we can call print, and that works fine, but you can see we actually print out that variable value here in the global scope, not in the local scope. We also cannot use variables defined in a different local scope. So for instance, here we have two functions, spam and bacon. And here inside of spam, we define the variable x, and then we call the function bacon, and then we print out x. And inside of bacon, we set ham to 101 and x to 0. Now if we call spam, we are going to print out x, and we define it in this local scope. And even though after defining the local variable x, we then call bacon before we print this out, bacon is in a different, or the variables inside of bacon are in a different local scope, so changing x to 0 actually has no effect. So when we run this program, we can see that we print out 99, which is defined inside of that local scope. So we can really think about local scope as a container or a walled-off garden. So pretty much anything inside of that local scope is only available inside of that local scope and not outside of it. However, it is possible to read global variables from a local scope. So here again we have a spam function that prints out x, the variable. Then we set it outside of the local scope. So in the global scope we set a variable x to 42. Then we call spam, which should print out x. And as you can see, we never defined x in the local scope of spam. But because x is defined outside of that local scope, it's defined on the global scope, it's still possible to access the variable here that's defined in the global scope in the local scope. So as we run that, we can see that we print out 42 twice. So the first time we are calling the spam function, and that function calls print on x, and x is defined outside of it. But since it's a global variable, we can print it out. And the second time here, we just call print in the global scope, so that of course works too. And that also highlights, at least somewhat, why it can be quite dangerous to define global variables, because if we have a very long program and we wrote x maybe at the very beginning of it, and we later on reference x, in the meantime we may have changed or worked with a different variable also called x, and then this may lead to some confusion because we basically have to look through our entire code and have a look at where we possibly defined it outside of the local scope in the global scope somewhere, and that can lead to some problems. So therefore, global variables are not a good practice to work with. And to highlight that problem a little bit more, we can actually use the exact same name for the global and local scope. So here we have two functions, spam and bacon, and we use the same variable x in the local scope of spam, in the local scope of bacon, and then also in the global scope outside of both of those function calls. Now here we are calling first the bacon function, which sets the variable x to bacon local and then prints it out. And then we call our other function, spam, which sets, or which has a local variable spam local and prints that out. Then we print out x again inside of the scope of bacon, and finally after that function call here we print out x on the global scope. So all of these times when we call x, in all those 4 instances here, we are using the same variable name, but we get different values. So first of all, of course, we define bacon local inside of the scope for bacon. So when we print it out here, we print out bacon local. Then we call our spam function where x is set to spam local, and we print out spam local. Then it's back to bacon, we print out bacon local, and finally we print out global. And this is called shadowing, when we are actually overriding or using the same name in different scopes, in the global and in the local scope. Now if instead we actually want to modify a global variable inside of a function, we need to use the global keyword. So in this case here we have our spam function, and we have a local variable x, which is set to spam. And then outside of it we have a global variable x, which is set to global. If we don't want to create a local variable here, but rather change the value of the global variable here, then we need to write global followed by the name of the global variable that we want to change. And then we can reference that global variable and change its value. So in this case here, we are calling spam, which is updating the value of the global variable x inside of that function and sets its value to spam. So as we print x, it should actually print out spam rather than global. And this is exactly what we get back. Especially when we're using the same name for a global variable and a local variable, it's really important that we assign the variable before we're actually using it. So as an example, we have here a global variable x, which is set to global, and a local variable x inside of a function, which is set to spam local. Now we are calling the spam function, and here we are printing x, and after that we define the local variable. Now since we are defining that local variable inside of the spam function, Python actually assumes that we are trying to use that local variable rather than the global variable. So as we try to run that, we get an error, and specifically we get an unbound local error, and it tells us we are trying to use the local variable x before it's actually assigned. Now if we wanted to indeed use the global variable, we could either change the name here and over here, or even if we comment out this line like this, we are not going to get an error because there is no assignment to a local variable anymore. Therefore Python assumes that this is indeed a reference to the global variable, but as soon as there's an assignment inside of the current block, inside of the current scope, we are actually running into this error because Python assumes that we want to use that local variable. The great thing about using functions is that we can oftentimes use them as black boxes. So we don't really need to understand what's going on under the hood. We just need to understand the input value and the output values we get. So we saw that already before when we worked, for example, with different functions from the random module, for example randint. We didn't really have to understand how that works or how that's implemented. Rather, we just needed to understand which kind of values we can pass to it and what we can expect as a return. And that's one of the fundamental principles of programming, that we can actually abstract away what's going on inside of a function, and we just can handle this as a black box and just need to understand what the inputs are and what the expected output is. Now so far, whenever we received an error in Python, or an exception as it's called, our entire program crashed. And in the real world, of course, we don't want that to happen. Let's take a look at a simple example. Here we have a function spam, which is called divide by, and we divide 42 by a number that's passed as an argument to this function. And while we're passing any non-zero value, that's not a problem. But of course, if we try to divide by 0, we are going to run into an issue. So here we can see when we pass 0 to it, we get a 0 division error and our program crashes. Now to avoid that, we can use a try except statement. And here we put the code that we try to execute inside of the try block. So similar to, for example, an if statement, we are indenting this. This creates a new block. And here we are trying to divide 42 by 0. But we are also checking for any errors. So here we are using the except statement and we are checking for 0 division errors. And if we encounter such an error, we are not going to execute the try block here and divide 42 by that number, but instead we are going to print the error message invalid argument. So if we pass the same arguments to our function as before, we can see that instead of getting an error, when we try to divide by 0, we are going to get an invalid argument error instead. So that's a much nicer way to actually handle that exception. Our program didn't crash, but we just printed out a dedicated error message. We can even leave the previous program intact, the same way it was before, and then just put our function calls inside of the try block and have a separate except statement here. So here we have all of the different function calls and we list them inside the try block, and whenever we encounter a 0 division error, then we're going to print invalid argument instead. So in this case here, we are going to execute the first two statements. The third one is invalid, would cause a 0 division error, and therefore we are printing that error message instead. At that point, the execution of the try blocks stops, so all other function calls are no longer executed. So that's really important to keep in mind. When we write real-world code, we want to always use a try except block to make sure that we don't run into some errors we may encounter. Let's take what we learned so far about functions and exceptions and write a little program together. And here we are using two additional modules, the time module and the sys module that we used before. And then we define an indent variable, set it to 0, and then we define a Boolean variable, indent increasing, and we set it to true initially. And then we are using a try block and an except statement here. We are using that because we are going to actually run a program that's printing out a certain pattern, and we are going to stop execution by pressing Ctrl+C, and by using this try except block we avoid a pretty ugly error message to be displayed. Therefore we are using this. Then we have an infinite loop while true, and we are printing out some empty space. We are calculating it by multiplying it with the number indent, which we're increasing later on. And in order to avoid that we always have a new line, we change the optional end argument, the keyword argument that we learned about before, and we set it to an empty string. Then we print a number of asterisk icons here. We make sure that there's a small delay so it doesn't really rush through the screen, but we have a 1/10 of a second delay. And then we are checking our Boolean value here, indent increasing, if it's set to true. So we're using a true C value here, and then we are increasing indent by 1. And if indent has increased to 20, then we are changing the direction by changing indent increasing to false. And then after that we are decreasing indent until it reaches a value of 0, and then we change it back to true, and we keep on doing that to print out our pattern. So if we take a look at our program, it's actually what it looks like. We basically draw these little stars here 20 times, and then we decrease it again, and of course it would run forever pretty much. We need to press Ctrl+C to actually stop execution. Now let's have a look at the practice questions. The first one is, why are functions advantageous to have in your programs? So we saw that functions are really useful if you want to execute some piece of code multiple times. So we avoid a lot of duplicated code, we avoid a lot of typing, and we can reuse the functionalities that we define by using functions. When does the code in a function execute? When the function is defined or when the function is called? So the code in the function executes when the function is called, not when it's defined. What statement creates a function? So we learned that we need to use the def statement in order to define a function. So we would, for example, say def hello, then a colon, enter, and then we would enter whatever should be part of the function. And of course, after defining the function, we need to make sure to call our function in order to execute the code. What is the difference between a function and a function call? So we have the function definition, where we basically define what the function is about, and then we have the function call, where we actually call or execute our function, and therefore execute whatever has been defined inside the scope of our function. How many global scopes are there in a Python program, and how many local scopes? There actually is only one global scope, which is outside of any function in a Python program, and when we define a variable inside of that global scope, a global variable, we can access it from the global scope, but also from the local scope, so pretty much from anywhere inside of our program. In terms of the local scopes, there can really be an infinite amount of local scopes. Whenever we define a new function, for instance, we would define a new local scope. And of course, we could write as many functions as we wanted. What happens to variables in a local scope when the function call returns? So when the function call returns and we are basically ending the execution of the local scope, then actually all the local variables inside of the local scope will get destroyed. They're no longer accessible. So if we need to transfer any data, we need to make sure that we use the return statement to actually get the result from the local scope back to the calling scope, for example, to the global scope. What is a return value? Can a return value be part of an expression? So a return value, basically whatever is returned from a function, we would use the return keyword followed by the value that should be returned. And we could also, after the return value, have an expression, for example, a mathematical operation, and then the result of that mathematical operation will be returned from that function. If a function does not have a return statement, what is the return value of a call to that function? So we saw before that, for example, the print function doesn't have a return value, so it returns the value none, which basically means nothing. So there's no value or anything that's returned, so therefore none is used. how can we force a variable in a function to refer to the global variable? So when we are just accessing a variable, we don't really need to do anything. We can just directly use that global variable. If we want to make a change to the global variable, we have to use the global keyword. So we would use global followed by the variable name of that global variable, and then in the next line we could change, for example, the value of that global variable. So the next question is, what is the data type of none? So none is actually its own data type, so it's literally nothing. So it's not another data type, but none is its own data type. So it refers to nothing at all. In other programming languages, it's for example called null or nil. What does the import "are all your pets named Eric" statement do? So that would import a module called "are all your pets named Eric," and that's basically just another Python file that's being imported, so we can then access any values inside of that module, for example any functions that we want to use. So if we had a function named bacon and a module named spam, how would we call it after importing spam? So we could do that as follows. We would first of all say we want to import the spam module, and then we would call bacon on it to call the bacon function inside of the spam module. And if instead we didn't use this syntax here, but instead of writing import spam, we wrote something like from spam import everything, for example, we don't need to reference spam. Instead we would just use bacon, the function call itself. How can we prevent a program from crashing when it gets an error? So for that we can use a try except block. So we would put the code we want to execute inside of the try block, and then the error handling inside of the except block. So what goes inside of the try clause, what goes inside of the except clause? Just as we just talked about, the try clause would include the code we want to execute that could actually lead to an error, and then the except clause would handle the error case. Typically we would print out some kind of message notifying a user that there was an error that occurred, so we don't actually crash the program. And finally we have a practice program here. So we should make sure that we write a function called Collatz, and that should have one parameter named number. And if number is even, then Collatz should do an integer division. So we should divide the number by 2 using integer division. That means we divide it by 2, and whatever remains after the decimal point is basically thrown out. So 5 divided by 2 using integer division would be, of course it would be 2.5, but since we use integer division it is 2, and then we should return this value. If the number is odd, then Collatz should print and return 3 times number plus 1. And then we should write a program that lets the user type in an integer, and that keeps calling our function on that number until the function returns the value of 1. And that actually works for any integer. Eventually we are going to get to a number of 1. And that's actually a mathematical problem here called the Collatz sequence. And just as a hint, we should make sure that we convert the return value from input to an integer so we can work with that. And so as an additional hint, we can use the modulo operator. If we divide a number by 2 using the modulo operator, then we know it's an even number, otherwise it's going to be an odd number. So let's have a look at that. There are many different solutions we could use, but this is one. We define our function Collatz, which takes one argument, which is defined as a parameter here, and then we check if our number is divisible by 0 using modulo 2, because that gives us the remainder of dividing the number. So if that's equal to 0, then we know that we can evenly divide the number by 2. That means it's an even number. And then we are using integer division to divide our number by 2. We store that in result, we print the result out, and we also return the result. And if our number is not even, if it's not divisible by 0, it's odd, and therefore we calculate the result as 3 times the number plus 1, print that out, and we also return it. And then when we ask the user to enter a number, we use the input function to get that input, and of course we need to convert it into an integer. So we are casting whatever the user types into an integer, store that in the number, and then we have a while loop that executes while the number is not equal to 1. We are actually calling our Collatz function, passing the number in, and storing whatever is calculated, whatever is returned here, back into number. And if whatever is returned here is not equal to 1, then of course we keep on looping through our while loop. So we are going to keep on executing our Collatz function, and depending on whether the number is even or odd, it's either going to be divided by 2 using integer division, or we're going to multiply the number by 3 and then add 1 to it. So let's run our program and let's enter a number such as 3 to it. And we can see when we enter 3 to it, we pass it to the Collatz function. 3 of course is odd, so therefore the if statement here is false. We execute the else statement, so we multiply the number by 3. 3 times 3 is 9, plus 1 is 10, so we print out 10, and we return 10 as a value, meaning on the next iteration, number is actually going to be equal to 10, so we pass that again to the Collatz function. 10 is even, therefore we divide it by 2, which gives us 5, so we print that out, and we keep on doing that until we end up with the number 1. If we run our program with a different value, let's say 4, then it just takes 3 iterations basically to get to 1, but it will always end up with 1. Now, there are some limitations to our current program. So for example, if a user is malicious or not careful and enters some text, for example, we're actually gonna get a value error. So we can cover that case by using a try except statement. And one way to do that is the following. We can use our try block and basically move our program that we're executing, that means the input we get, and also our while loop inside of the try block. And if we get a value error, which is the error we just got before, then we can print out a statement, for example, invalid input, you must enter an integer number. If we run that again and we type something in, then instead of getting that ugly error message, we get that more descript print statement that's being printed out, so the user knows what they can actually do to solve that. So to briefly recap what we did, we learned about functions, and we learned that it's a really good way to compartmentalize our code into logical groups. We can also use functions to organize our code to get some clear structure. We also learned about working with try and except statements to cover any error cases that can happen. Now in the next video we are going to learn about a different data type called lists. They are super useful when working with larger programs, and we're going to cover that in the next video. So feel free to subscribe to get notified when a new video is released, and see you guys in the next video.